Assalamu alaikum students. The last lecture was about the logical statements as well as compound statements, and we discussed about the logical connectives to make logical expressions from the simple logical statements. Today's lecture is about the conditional statements, and we use another logical operator which is known as implies operator to make the conditional statements. In today's lecture, our focus will be on the conditional statements as well as how to decide the truth value for the conditional statements, and we learn about the construction of truth tables for the conditional statements and to convert the conditional statements into implication form. In order to understand how a conditional statement looks like, let us consider an example. If you get A grade in formal methods, then I will buy a computer for you. This statement has two parts, and we represent both the parts symbolically. The first part is represented by symbol P, which is actually you get A grade in formal methods, and the second part is represented by symbol Q. I will buy you a computer. The original statement is then saying if P is true, then Q is true, and more simply if P then Q, and we can also describe such kind of statements as P implies Q, and symbolically in a logical expression we write P implies Q, and we use this implies operator to represent the conditional statements. Let's understand the formation of the conditional statement, and for the sake of argument, for the given statement, if you earn an A in formal methods, then I will buy you a computer is true. All it says is that if you do so, then I will buy you a computer. And we can consider the conditional statement as a promise. And the only way that is that it can be broken is that if you do earn an A grade and I do not buy you a computer. In general, we use this idea to define the conditional statement in the form of if P then Q, or P implies Q. Students, in order to elaborate the semantics or meanings of the conditional statement, let us consider another example of conditional statement. If you show up for work Monday morning, then you will get the job. In this conditional statement, the owner's promise only says you will get the job if a certain condition is met, which is showing up for work Monday morning. Students, it is very important to mention here that such kind of statements say nothing about what will happen if the condition is not met. So in the above given conditional statement, this conditional statement says nothing that what would happen if you do not show up for work Monday morning. So such kind of conditional statements are one-way conditional statements. Students, conditional statements have two parts. The first part is known as if part, and the second part is known as then part, and it is represented by the conditional operator. If we have two statement variables P and Q, then we can say that if P then Q, or P implies Q, is a conditional statement, and in the logical expression we can represent P conditional operator Q. As I mentioned earlier, that it has two parts. The if part is also known as a hypothesis part or antecedent part, and then part is also known as conclusion part or consequent part. And we have already discussed that conditional statements can be considered as promise, so its truth value can only be false when P is true and Q is false. In other words, if the if part is true and then part is false, or the conditional statement is considered as false when its antecedent part is true and its consequent part truth value is false. In order to construct the truth table for the logical conditional statement, we have all possible input combinations for truth values is equal to 4 because there are two variables in the logical expression. So the formula to get the all possible input combination of truth value is equal to 2 to the raised power the number of variables in the expression, and 2 to the raised power 2 would be 4. So there are 4 rows in the truth table, and we have discussed earlier that there are two parts in the conditional statement. Its if part is known as antecedent part and its then part is known as consequent part. Students, when both the truth values for the antecedent part as well as consequent part would be true, then the overall truth value for the conditional statement would be true. And when the antecedent part truth value is true and the truth value for the consequent part is false, then this is the only condition where the truth value of the conditional statement would be false. And whenever we have the truth value for the consequent part is false, and whatever value truth value of the consequent part, then the overall truth value of the conditional statement would be true. So it is important to note here that the conditional statement would only be false when the truth value of the antecedent part is true and its consequent part truth value is false. Then the overall truth value for the conditional statement would be false. And we have mentioned that we can consider the conditional statement as a promise. Therefore, the only way to break the promise is that its if part truth value is true and its then part truth value is false, then the conditional statement would be false, or you can say that the constraint or condition given in the conditional statement has been violated, or therefore we can consider its truth value as false. Now we discuss how to decide the truth value for the conditional statement in the truth table. You can consider the conditional statement P implies Q, and its truth value would only be false only when P is true and Q is false. In order to assign the truth value in the column of P implies Q, first we have to find out rows where P is true and the corresponding column where Q is false. Then we will write F in the corresponding column, and all the other columns of the truth table for the conditional statement would be true. It is important to note that if antecedent part of the conditional statement is false, and whatever the value of the consequent part, we will write T in the column of P implies Q. In order to explain the truth value for the conditional statements, let us consider a very interesting example of the conditional statement, which is if there are no clouds, then there is no rain. And we can represent the conditional statement symbolically, and we have variable P which represents there are no clouds, and Q is representing there is no rain. So the truth value for the statement P is true mentions that there are no clouds, and the truth value for the statement Q is true mentions that there is no rain. If there are no clouds, then there is no rain, so logically its truth value would be true. And if there are no clouds and there is rain, so this phenomena is wrong, and logically its truth value would be false. And if there are clouds and it would say nothing that what would happen, therefore the default value or default truth value for the conditional statement would be true. And you have observed whenever there are clouds, then anything can happen. There may be rain or there may not be rain, and its logical truth value for the whole conditional statement would be true. Students, let us practice the truth value for different conditional statements. We have first conditional statement, which is if 1 is equal to 1, then 3 is equal to 3. So what will be its truth value? Yes, of course, its truth value is true because the truth value of its if part is true, and the truth value of its then part is also true. Then overall truth value of the conditional statement is true. Now what do you say the truth value about this conditional statement? Yes, it is false because the truth value of its if part or its antecedent part is true, but the truth value of its consequent part or its then part is false. Therefore, the overall truth value is false. If 1 is equal to 0, then 3 is equal to 3. What do you say about the truth value of this conditional statement? Yes, it is true because whenever we have the truth value of the if part of the conditional statement is true, then whatever the truth value of its consequent part or then part, the overall truth value would be true. Now you can easily decide the truth value for this conditional statement because its if part is false, 1 is equal to 2 is false, then there is no need to look at the consequent part, its overall truth value is true. Now how can you explain the truth value for this conditional statement? You can say that its antecedent part is true and its consequent part is also a compound statement containing conjunction operator, and it is false because 1 is equal to 2 and 2 is equal to 3 is false. Therefore, whenever we have if part is true and then part is false, then overall truth value is false. Now you can decide the truth value for this conditional statement. If 1 is equal to 3 or 1 is equal to 2, then 3 is equal to 3. Now the conditional statement contain two parts, and its if part is again a compound statement having disjunction operator or operator, and the overall truth value of if part is false, then the truth value would be true because there is no need to consider the truth value of its then part. Whenever we have the truth value of if part is false, then overall truth value of the conditional statement would be true. Students, the conditional statement in the form of if P then Q can be expressed in many alternative ways. For example, we can say this conditional statement if P then Q, or P implies Q, or if P Q, and another alternative way P only if Q, and we can also express as P is sufficient for Q, and other alternative ways are not P unless Q, Q follows from P, Q if P, Q whenever P, Q is necessary for P. So all these given expressions can be used to describe the conditional statement in the form of P implies Q, or if P then Q. Now let us discuss a logical expression having conditional operator with three variables. Its first variable is functioning, which is the reactor is functioning normally, and second variable is valid command, which is actually a statement a valid command has been typed. The third variable is executed, which is actually a logical statement, which is the command will have been executed. Then the logical expression functioning and valid command implies executed stand for the proposition or compound proposition in the form of if the reactor is functioning normally and the valid command has been typed, then the command will have been executed. Students, the given compound statement can be converted into such kind of logical expression using the conditional operator. Students, there is an exercise for you to convert the given conditional statements into the form if P then Q. The first conditional statement is given as your guarantee is valid only if you bought your CD less than 90 days ago. Students, the given conditional statement is in the form of P only if Q. So its first part is your guarantee is valid, or its P part is your guarantee is valid, and its Q part you bought your CD less than 90 days ago. Therefore, its if P, then Q representation would be, if your guarantee is valid, then you must have bought your CD player less than 90 days ago. The second conditional statement, to get tenure as a professor, it is sufficient to be world famous. Students, this conditional statement into the uh, sufficient form, and the sufficient form is its P form or its if part. Therefore, when we convert into if P then Q form, it would be, if you are world famous, then you will get tenure as a professor. The third conditional statement is in the P implies Q form, that you get the job implies that you have best credentials. Then its if P then Q form would be, if you get the job, then you have the best credentials. The last conditional statement has the necessary part, and the necessary part is the consequent part of the statement. Therefore, its if P then Q representation would be, if you get the job in the software house, then you must have practiced 8 hours. Now we practice to translate the given conditional statements into logical conditional expressions. We have three logical variables P, Q, and R. P represents you get an A on the final exam. Q is representing you do every exercise in this book, and variable R is representing you get an A in this class. So we write the compound propositions choosing P, Q, and R and logical connectives, and we convert it into a logical expression. The first uh, compound proposition, to get an A in this class, it is necessary for you to get an A on the final. So its logical expression representation would be P implies R, because the necessary part is then part or consequent part. You do every exercise in this book, you get an A on the final exam, implies you get an A in the class. So its logical expression would be P and Q implies R. Similarly, getting an A on the final and doing every exercise in this book is sufficient for getting an A in this class, and the corresponding logical expression would be P and Q implies R. Now we explain the hierarchy of operations for logical connectives in compound statements, or we discuss the precedence of operators in logical expressions. The highest priority or the higher precedence is given to the negation operator. So whenever we have a logical expression, we will apply negation first, and the second precedence will be given to the conjunction and disjunction operator, and the third priority is given to the conditional operator. Students, it is important to note that we apply the operators in the logical expression from left to right. Students, we discuss the precedence of operators in a complex logical expression, and we discussed that the negation operator has the highest priority. Whenever we have the same operators, then the sequences of the same operators are evaluated from left to right. For example, we have a logical expression old file or new file or updated file is equivalent to old file or new file will be evaluated first because we move from left to right, and then we evaluate the first evaluated expression to the last uh, variable logical variable, and this is the hierarchy or precedence for the similar kind of operators, that whenever we move from left to right we apply the operator. The order of evaluation of different but adjacent operators is given by the following order of precedence. First we apply the negation, then conjunction or disjunction, and then conditional operator is applied, and at the end of the evaluation of expression we evaluate the biconditional operator. Therefore, negation has the highest order of precedence and the biconditional operator has the lowest order. In order to decide the truth value of the given logical expression, P or not Q implies not P, as you can see that this logical expression contains negation operator, disjunction operator, and conditional operator, and we have discussed earlier that the negation operator has its highest priority, or the negation operator has the highest precedence. Therefore, we can evaluate the truth value for the expression not Q and not P. As you can see that all possible combination of input truth values is equal to 2 to the raised power the number of variables in the expression, and there are two variables in the expression, so there would be four possible combination of input truth values, and there are four rows. And first we evaluate not Q and not P, and then we evaluate the expression P or not Q, because the second precedence will be given to the disjunction operator, and at the end of the evaluation of the expression we will evaluate the overall expression containing conditional operator, and we will get the output truth values for the given expression. In order to decide the truth value for the given logical expression, let's look at the given expression. The expression has two parts, which is separated by round braces, and as you can see that in the second part of the logical expression contain negation operator, which has its highest precedence, and in order to construct the truth table for the whole expression there would be 8 rows in the truth table, because there are 3 variables in the given logical expression, and the formula says that there would be 2 to the raised power of 3 is equal to 8 possible input combination of truth values, and there would be 8 rows, and After evaluating the negation part, not P, we can evaluate the first component, P is implies Q, and then we evaluate the second component, not P implies R, and at the end we will uh, evaluate the truth value by combining these two parts with the conjunction operator, and we'll get the overall truth value in the last column of the truth table. Students, it is interesting to note here that the truth value for the logical expression P implies Q is equal to the truth value of the expression not Q implies not P, and to show that both the expressions are logically equivalent in the form of truth value, we can construct the truth table for both expressions, and you can see that the overall truth value for the expression P implies Q and the truth values for the expression not Q implies not P is same. Therefore, we can say that both expressions are logically same. Students, in the previous slide, we showed that the conditional statement P implies Q is logically equivalent to the conditional statement not Q implies not P. Here we are going to show that the conditional statement P implies Q is logically equivalent to the compound statement not P or Q, and this is known as a very important implication law. So what the implication law says, that P implies Q is logically equivalent to not P or Q. In order to prove that, we can construct the truth table for both expressions. For P implies Q, we have the following output truth values, and for the compound statement not P or Q, we have the following truth values. In the above table, as you note that the entries in the third and last columns are same, so these statements form are logically equivalent. This is very important logical equivalence, which is known as implication law, and which shows that the implication can be replaced, or conditional operator can be replaced by the negation and disjunction operator. So implication can be replaced by using negation and disjunction. In order to explain the meaning of implication law, let us consider a compound statement. Either you get to work in time or you are fired. The given statement is in the form which is not P or Q, where not P is equal to you get to work in time and variable Q is equal to you are fired. Now by taking the negation of not P, we will get P, which would be equal to you do not get to work in time. And if we rewrite the given compound statement into if then form, then we can explain in that way: if you do not get to work in time, then you are fired. Therefore, either you get to work in time or you are fired is logically equivalent to if you do not get to work in time, then you are fired. So implication law explains that the conditional statement, which is if P then Q, can be converted into not P or Q. Students, we have discussed that the implication law can be used to simplify the conditional statement. Therefore, if we have a conditional statement in the form if P then Q can be converted into a simplified form which is not P or Q, and if we apply the negation on the statement if P then Q, then we can put the equivalent expression for the if P then Q which is not P or Q. Thereafter, by applying the De Morgan's law, we will get not P and not Q, and which can be converted into more simplified expression which is P and not Q. Students, thus the negation of if P then Q is logically equivalent to P and not Q. Accordingly, the negation of an if then statement does not start with the word if, and we can observe that the negation of implication and the implication are not logically equivalent. Students, you can construct the truth table for the negation of implication and for the implication law, and you can observe that the truth values for both expressions, which are P and not Q, and other is not P or Q, would not be equal. In this lecture, we discussed about the conditional statements. We discussed the structure of conditional statement, and we also elaborate the truth value for the conditional statements, and we learned how to construct the truth table for the conditional statement. And at the end of this lecture, we discuss the implication law and how can we convert the conditional statement if P then Q into a simplified form which is not P or Q. Students, the contents of this lecture are taken from section number 3.2 of chapter number 3 of the book Software Development with Z, and there is another chapter which is chapter number 2 of the book for Formal Software Development from Medium to Java. Student, you must read both the chapters of both the books to understand the concepts discussed in this lecture. And that's all for today's lecture. Allah Hafiz.